maximal domain and range. So the best way to do it is to do some rearranging and work out your x and y values to satisfy the given conditions, depending on whether it's inverse cos, inverse sine, or inverse tan. Now we're also going to sketch the graph of these. Now it doesn't say to sketch the graph, but I think it's good practice to do some graph work, because these do come up in the exam quite often. So I think it's good practice. So we'll have a look at the first one, and then I'll give you some time to have a go at the second one. So if we look at y is equal to 2 inverse cos 2x plus 1, the way I like to do it is to rearrange and get it in the form of y is equal to inverse cos of something. So I'm going to subtract 1, divide by 2, and that's equal to inverse cos of 2x. And I know that this thing, because it's inverse cos, has to be between 0 and pi, and this thing has to be between -1 and 1. So if you divide through by 2 to get the domain, x is going to be between -1/2 and 1/2. If we rearrange here, y minus 1 is going to be between, multiplying through by 2, is going to be 0 to 2 pi, which means that y is going to be between, if we add 1 to everything, 1 to 2 pi plus 1. So that's our maximal domain and range. And I think if we have a look at sketching the graph, the way I like to sketch is to make sure that I create my domain and range and form, if you like, a box. So if there's my y-axis, there's my x-axis. I know my x values are between -1/2 and 1/2 if we put it at that sort of length. My y values are between 1 and 2 pi plus 1. So 1 might be there. 2 pi plus 1, well, pi is around about 3.5. 2 3.5s are 7, plus 1's about 8. So it might be up here somewhere. So that would be 2 pi plus 1. And then I need to cut my box in half. So this would be pi plus 1. And I know it's my standard inverse cos graph. There are no reflections. And my standard inverse cos graph would go something like that. Now, normally on the exam, they will often say label your endpoints. So that would be at x is 1/2, y is 1. That would be at -1/2, 2 pi plus 1. And that would be your graph. And if you wanted to check, if you put in x equals 1/2 into your expression there, you'd end up with y is equal to 2 inverse cos of 1 plus 1. Inverse cos of 1 is 0. So that would be 1. So we are on the right sort of track. So can I suggest that when you're sketching these inverse trig function graphs, particularly for inverse cos, inverse sine, always, even if it doesn't ask you for it, always work out the maximal domain, maximal range, create your box if you like, and then once you've got that box, divide it up into 4, and then sketch the relevant inverse trig function. I think if you apply that sort of method, they're not as difficult as what they might seem. So